Kinematics example 2. A particle moves in a straight line so that its displacement from O is given by s of t as 2t cubed minus 15t squared plus 36t take away 10. We want to find the initial displacement, velocity and acceleration of the particle and represent them on a diagram. So initial means t equals 0. So s of 0 is going to be negative 10 meters. Let's just assume meters per second unless we're told otherwise. So the velocity would be the differential of this. So that's going to be 6t squared minus 30t plus 36. So v of 0 is going to be 36 meters per second. The acceleration we get by differentiating the velocity. So that's going to be 12t minus 30. A of 0 is then negative 30 meters per second squared. So if we have a diagram here for the particle, let's put O here. The initial displacement is negative 10. So we'll put it over here so that this distance is 10 meters, and it's to the left of O because it's negative. The velocity is in this direction because it's positive, so that's 36 meters per second. But the acceleration is negative. Acceleration is usually shown with a double-headed arrow, and we can say that that's 30 meters per second squared, and the arrow going to the left indicates it's in the negative direction. Draw sign diagrams for the velocity and acceleration. Well, we know that v was 6t squared minus 30t plus 36. We'd like to know when it's 0. So let's put 6t squared minus 30t plus 36 equals 0 and divide through by 6. So t squared minus 5t plus 6 is equal to 0. So that gives me t minus 3 and t minus 2 equals 0. So t is equal to 3 and t is equal to 2. So if we have the velocity up here, and here's 2 and here's 3, so let's think about to the left of the 2. So let's take a value like 0. Well, we know from before that v of 0 is 36, so it's positive there. What about trying 2.5? So what we want to do is just bring in the calculator. And so we've got 6 multiplied by 2.5 squared. Take away 30 multiplied by 2.5. Add 36. Gives me negative 3 over 2. So that gives an indication that the velocity would be negative in between here. And then if we go to the right of 3, try something like 4. So probably need the calculator back again. Let's change all those 2.5s to 4s. So 4, and there's only one more to go. So let's make that one into 4. And that's 12. So that means positive here. So there's a sign diagram for the velocity. So now let's try the acceleration. So the acceleration was 12t take away 30. And we're interested in when that's 0. So 12t minus 30 is equal to 0. 12t is equal to 30. So 30 divided by 12 is 2.5. So the acceleration is 0 at 2.5, which interestingly is halfway through that gap. So this is the acceleration, and we know at 2.5 that it's 0, and then let's look to the left. So let's take something like t equals 0, that's negative 30, so that's negative over here. Take something to the right like 3, 12 times 3 is 36, take away 30 is positive, so it will be positive there. Find the position of the particle when the changes of direction occur. Now, we know that the velocity sign graph changed at 2 and 3. We had positive direction, negative direction, positive direction. So these are where the changes happen at t equals 2 and t equals 3. So we want s of 2, which is just a case of substituting 2 in to this expression. So we've got 2 multiplied by 2 cubed, take away 15 multiplied by 2 squared, plus 36 multiplied by 2, take away 10, not 110. So that's 18. So that would be 18 meters. And then we want s of 3. Well, we can just go back and edit the 2's into 3's in here. So let's change those. And that gives me 17 meters. So s of 3 is 17 meters. Draw a motion diagram for the particle from t equals 0 to t equals 5, and hence find the distance travelled in the first 5 seconds. Okay, so we knew that s of 0 was equal to negative 10. We worked that out much earlier. The changes in direction happen at 2 and 3, and we know the displacements at those. What we don't know is s of 5. So we need to work that out. And fortunately all we need to do is go through and change the 3's into 5's because it was the last calculation I did. So that's 45. So if we think about our object, if O is here, it starts off here, and that's at negative 10, and then of course this is when t was 0, and then it's going to arrive over here, so that this is 18 at t equals 2, and then it's back a little bit from there at t equals 3 at 17, and then at t equals 5 it's right over here at 45. So how has our object travelled? It's gone from here to there, it's then gone back to there, and then gone forward like so. So the total distance travelled is going to be 28 going from there to there, then 1 going backwards, and then 28 going from the 17 to 45. So 28 and 28 is 56, and 1 is 57. So the total distance travelled is 57 meters. Find the speed of the particle when t is 1, t is 2.5, and t is 4. Now we know the velocity expression is 6t squared minus 30t plus 36. So v of 1 is going to be 6 minus 30 plus 36. So that's equal to 12 meters per second. And so the speed is 12 meters per second. When t is 2.5, v of 2.5 is equal to 6 multiplied by 2.5 squared minus 30 times 2.5 plus 36. And I think we best calculate that. So we've got 6 multiplied by 2.5 squared. Take away 30 multiplied by 2.5. Add 36. That gives me negative 3 over 2. So negative 1.5. So the speed is 1.5 meters per second. Speed is a scalar. Velocity is a vector, so the direction is important, but with speed you ignore negative signs. And then we want v of 4. So let's get the calculator back up and we'll change the 2.5s to 4s. Thought I did this calculation earlier, but I've actually forgotten what the answer was. And that's 12. So that would be 12 meters per second for the velocity. And because, of course, it's positive, that means the speed is 12 meters per second.